Do you desire to build an elite cloud architect career, solution architect career, or cloud engineer career? If so, this video is for you. In this video, we are going to teach you about the cloud, and then you'll know how to work on multiple clouds. And we're going to show you how the cloud is nothing more than a network and a data center that's been virtualized. We will teach you the network and data center services, or at least some of them that you will need to know. And then you will understand the equivalent services on the cloud. So you'll know how to migrate those services to the cloud. Let's begin. But before we do, I want to tell you my background. I've been working in this technology industry for over 25 years. And I've spent the last 20 years helping others get their first tech job or get promoted in tech. And of course, I want to help you get cloud hired or cloud promoted. So we're first going to start with the most fundamental element of cloud computing, virtualization. Virtualization is what makes cloud computing possible, and I love virtualization. Now, virtualization is not new. It's about 50 years old, and IBM initially invented it. And then after that, about 20 years ago, we had modern virtualization, and VMware created server virtualization, and that's what we're going to talk about today. Now, we will also tell you the equivalent services on the cloud so you know exactly what to use and where, but we want you to truly understand server virtualization and why. To take those virtual servers from the network and the data center to migrate them to the cloud, you need to know what they are. And by the end of this discussion, you'll not only know what they are, you'll know what they are on Azure, Google, and AWS, and be prepared to work on any of them. So let's talk about server virtualization, one of my favorite things. If we go back to the old days, 25, 30 years ago, we had very small capacity servers. Maybe they had a CPU core. Maybe they had a couple of megs of RAM. And in those days, one server was for one application. And in many cases, we need multiple servers for a small application. And that's what we used to do. And then the servers started getting 2 cores and 4 cores. And now we're up to 128 cores. And now you can get a good 6 terabytes of DRAM all in a physical server. Now, most applications don't need a giant server like that. So what would happen is we could either buy these big, fancy, $60,000, $75,000 servers, and they could be 2% used, sucking up our electric and sucking up our financial resources, or we could take these same servers and use them for multiple applications. Now, single set of electricity, single space on our racks, efficiency in terms of real estate, efficiency in terms of power, and efficiencies in terms of cost. Because now that $60,000 or $70,000 server might replace 30 servers or 40 servers. Or if it's going to be used for containers, which we'll talk about later, it might host 100 containers. But let's really talk about how this works. See, what happens is now that the servers are powerful, we want to find a way to use them. And that's where server virtualization comes from. So we take our servers and we chop them into logical mini servers. So instead of having one server, we've got a bunch, which is great. So what do? We take our physical server and we have to install a thin layer of software on it that's going to divide the server up into mini pieces of that server and divide the CPU cores, the memory, the storage. Now that software is called a hypervisor. So we have a hardware. We layer our hypervisor, and from there, we create our virtual machines. In our virtual machine, we tell it how many CPU cores we need, how much DRAM we need, the type of hard drive, etc. And then we install an operating system on each virtual machine, just like any other computer, and we install our applications. And bingo, now we've got multiple servers. Now, if we've got 128 cores, chances are we've got a bunch of 4-core servers that we can put there, or a less number of 8-core servers, or an even smaller number of 16-core servers, or how many 32-core servers? So you get the point. By doing this, we can take one server, chop it up into multiple servers. How does it work? The hypervisor, that's the magical secret weapon to making this work. Bare metal, we take our server, we install just the hypervisor, no operating system, and then we've got our virtual machines, and each one has their own operating system and their own applications. Great way to do virtualization. Still the primary form of computing on the cloud, virtual machines. Now we've talked about a type 1 hypervisor, which is server virtualization. And guess what? On the cloud, we'll tell you how to find these. Well, in your data center, it's typically sitting on VMware KVM or QEMU, three of the more common hypervisors. On the cloud, if you're getting it from AWS, it's going to sit on an EC2 instance or Elastic Compute Cloud. And if you're on Azure, well, they're going to call it a virtual machine. They call it an Azure virtual machine. If you're on Oracle, they also call it a virtual machine. But if you're on Google, they call it a compute engine instance. So now you know, we strip away all these fancy names. What is it? It's a virtual machine. Now this is a type 1 hypervisor. This is what we use with server virtualization. Now because we were talking about server virtualization and type 1 hypervisors, I wanted to make sure there was no confusion. So what am I referring to here? Many of us, like me, I use a Mac, and every once in a while there's some program I have to use Windows for. Or better yet, when I used to use Linux, there was always some program that I needed to use Windows for. And because of that, I always ran a virtual machine on my computer. But it was not the same kind of virtual machine we were talking about. So many of you, for example, have Macs and you want to run a Windows virtual machine. And when you do that, what you have is a type 2 hypervisor, which is nowhere near the performance of a type 1 hypervisor, but it has a different use case. Now, in this case, we have our physical hardware. Say it's our notebook. We have our operating system. Say it's Red Hat Linux, or guess what? My favorite, Mac OS. Well, at least for use, so I can write Word documents on it. And then I would have a hypervisor. Now note in this case, we had the hardware, the operating system, and the hypervisor which runs on top of the operating system. Hence it's slow, because the operating systems are another layer away from the physical hardware. And here what would we do? Then we would install our virtual machines, which would have, of course, their own memory and CPU and hard drive resources. But the fact that they're running inside of an operating system slows them down. So this is not what we're going to use for server virtualization, but many of you have worked with it in the past with via VirtualBox or VMware Workstation or Parallels, and I wanted you to know what they are. Understand this, and you'll be good to go and get yourself cloud hired or cloud promoted, because it's critical information for the cloud architect, solution architect, enterprise architect, or cloud engineer. Critical information for our world. So now let's talk about the next form of computing on the cloud. It's called the container. So virtualization is not new, and the concept of the container is not new either. In networking, we had something called the private VLAN, which the VLAN was basically a server virtualization, but for virtual switches. And then we came up with the private VLAN, which meant one user inside of a VLAN couldn't talk to another user inside of the same VLAN. And now, in compute, we've got the same thing. We basically created an environment called the containerized environment. What does the containerized environment really do? In simple terms, it almost basically virtualizes your operating system. So with a container, we can have one virtual machine or one physical server, doesn't matter. And here we can have an application in a container, and another application in another container, and another application in another container. And it's beautiful. Now, what happens on one container should have no impact on another container. Well, that's great. So that means security and performance. So let's think about this just for a minute. We will have our physical hardware, we will have our host operating system, and we will have a container engine. So hardware, operating system, and now container engine. Now we're also usually going to have something to orchestrate the containers, but we don't need to go there right now. And remember, in virtualization, we had virtual machines, and each virtual machine had their own operating system and their own application. But with the container, all we're going to have is the container, some system libraries, and our applications. And why do the containers work? What happened when we build the container pulls things from the operating system's libraries, so it doesn't need to run another virtual machine with its own operating system. It's leveraging the operating system libraries on the primary operating system. Why does this matter? Well, if you're going to run a container on your Mac, guess what? You can't move that container to a Windows system because it's dependent upon the containers and the libraries on your Mac. Likewise, if you built something on a Windows system, you can't port it to a containerized environment on a Linux server because it needs the operating system libraries. So keep that in the back of your mind. What is a container? Physical hardware, OS, container engine, an isolated container, library, an application, library and application, library and application. And because of this, containers are very lightweight. No operating system means we can save lots of RAM, lots of memory resources, and the containers are fast, so fast and light. And a server that might only be able to do 10 virtual machines might be able to do 50 containers because they're so efficient. So containers, for the most part, are the virtualization of the present and the future. Now, granted, the majority of the work is still being done on virtual machines, but containers are there. Now, virtual machines will always be used for things that need high performance and lots of memory and compute power. But for things that don't need it, the containers are a very efficient strategy. It's almost as if like they virtualize your operating system. And here's why. You got a container and another container. They can't talk to each other. It's great. If container A crashes, it should not have an impact on container B because they're logically separated. So containers are wonderful. High performance, low overhead, and another form of computing. Now in the data center, we've got Kubernetes. We've been using it for a while. In the cloud, we still have Kubernetes. We can use the Elastic Kubernetes service with AWS. We could be using Red Hat OpenShift, for example. We could be using the Azure Kubernetes service, the Google Kubernetes engine, and there we go. We've got managed Kubernetes orchestration systems in the cloud. But guess what? Whether we wanted to run a Kubernetes cluster off of virtual machines, we can do it in the cloud just like the data center, or with the cloud, we've got managed services for these things. But now you know, Kubernetes or containers and container orchestration has been around. It's the same thing in the data center. Maybe it's running Kubernetes, maybe it's running OpenShift, which is kind of the same thing, or in the cloud. Like I said, Elastic Kubernetes service with AWS, Azure Kubernetes service with Azure, and Google Kubernetes service with Google. Same thing. Let's not get far from what we really started, and we know all clouds. And now it's not the name of the service and how to configure it. It's the cloud. All clouds, they're all the same. So now let's talk about one of my favorite devices, the load balancer. Why do I love load balancers? Load balancers increase performance and availability. Wow, performance and availability in the same device. Load balancers are really cool. So why do load balancers do this and how do they work? Well, a load balancer distributes the load across multiple devices. So by sharing the load across multiple devices, we remove single points of failure. Imagine having one server. It fails. Guess what? Let's assume this is a web server. Website's down. Now, how many businesses want their website down? Not many. So if they had used two smaller servers instead of one bigger server, and one of those small web servers went down, guess what? We still have another web server. So the point is we use load balancers to improve performance and availability. Now we've got two kinds of load balancers as a rule. We have network load balancers and we have application load balancers. And whether you're dealing with a physical device like the F5 load balancer or a virtual load balancer, it doesn't matter. They all work the same way. So I want you to understand, what is a load balancer? A load balancer is a device or a logical device, it doesn't matter, that will take your traffic and distribute low load. Now let's talk about how they work. Why do we use network load balancers? Because they're really fast. We use network load balancers to load balance usually between big bad servers, like the 128 core kind, or between firewalls, or between network devices. So we use network load balancers when we need speed. Why are network load balancers fast? Let's talk about how they work. You basically have when you deal with your OSI model, you've got layer 4, which is your TCP and your UDP, your transport. And what's going on is this load balancer looks at layer 4, the protocol, TCP, UDP, the source and destination addresses, and they are really fast. They send the data through as fast as possible, in, out, and it's fast. And that's why we use network load balancers. Why are they fast? They don't have to do a lot of work. The computations are simple. Imagine if we decided to do 2 times 2 all day long. 2, 4, 8, 16, 32, 64, 128. You get to the point, if you wanted to do something like that, it's pretty easy. Now, let's do that with calculus. We're going to get really slow, because we have to slow it down to process it. Now let's look at the application load balancers. When do we use them? When we need intelligence, when we need deep packet inspection, when we want to have intelligence in our routing. So now we've got an application load balancer. It's not fast. It can't be. Why can't it be? It's doing a lot. It's smart. It's looking at layer 7. It's looking at an HTTPS header, for example. And it's looking at the protocol and the source and the push and the get and all this information and the headers. And by that, it's going to make an intelligent decision. So because of that, it is really slow. Now in the data center, we typically get load balancers. I've often used them from F5, but there's other load balancer vendors, and these are great devices. In the cloud, we also have load balancers, and guess what kind we have? network load balancers and application load balancers, the same as we have in the data center. But on the cloud, now they're logical. So if we wanted to get a network load balancer in the cloud, we get it from all of them. But when we're dealing with AWS, they call their load balancers elastic load balancers. Azure calls their load balancers Azure load balancers, and Google calls their load balancers cloud load balancers. And guess what? They're load balancers, and you can select between application and network, just like any other load balancer. Learn the network in the data center, learn the cloud. Now you know the load balancer in the data center, and guess what? You now know it in the cloud. Now let's discuss storage. When we discuss storage, we're going to describe the three kinds of storage we're going to find in the data center: object storage, block storage, and file storage. And guess what? These are the same types of storage we're going to find on the cloud. But we're going to teach you how they work and why you would use each one. And we'll teach you what they're called in the data center. And from there, we'll teach you what they're called on each of the cloud providers. So that way you know the cloud instead of just merely the name of a cloud provider service or how to configure it. So now let's talk about object storage. Object storage is widely used in the data center and the cloud. And object storage is an exceptional type of storage. But object storage is not like regular storage. See, object storage is a type of storage area network. So what's going to limit its speed and performance? The network. So first you have to remember it's network-based storage. Now, object storage, you also have to understand, is only good for a write once, read many time environment. You can't use it like a local hard drive. Servers don't mount object storage like a regular drive. Object storage is used for backup and archival purposes, sharing and distributing software, sharing images and videos, those types of use cases. Object storage is not traditional storage. The reason object storage can't be used as traditional storage is the way object storage functions. See, object storage, anytime an object gets touched or modified by even a minimal percentage of a percent, it creates a new version. So imagine you had a computer that had a swap file that's a terabyte big. And imagine that swap file was modified by the operating system 1,000 times per minute. Well, then you would have 1,000 1 terabyte objects sitting in your object storage inside of a minute. That would fill up your systems, and obviously that doesn't work. So to better understand object storage, let's talk about how it works. The way object storage works is as follows. We have data. We always have data. But we break that data down into something called an object. Now, when we break the data down into these cool objects, we actually create something called metadata, which is data about the data. And because we have data about the data with object storage, we can do some really cool things. So for an example, we can search for our data or query for it because we've got this metadata. We might only need to retrieve part of an object instead of the full object and save time and networking performance and bandwidth. See, object storage gives us this information. But as I mentioned before, object storage is not traditional storage. It doesn't deal well with things that are changed. So object storage is used for write once, read many times. Now, the last thing about object storage is it's fantastic for big data environments. And why? See, object storage has metadata, which means you can take that metadata and use it for the creation of data lakes and other big data environments. So object storage, fantastic storage platform, highly scalable, but write once, read many times, not mounted or used by computers, used to back up, used to share information, and used to create big data environments. Now, in the data center, we call it object storage. Whether that comes from Dell EMC or IBM, it's object storage. But on the cloud providers had to make up their own names. So with AWS, you're dealing with S3. With Microsoft, you're dealing with Azure Blob. And with Google, you're dealing with cloud storage. But guess what? It's object storage, and it works and feels the same on all of these clouds. It doesn't matter which cloud you're on. So learn object storage. That's why we talked about it. And you'll be good to go as a multi-cloud architect, multi-cloud engineer. Now, the next type of storage we're going to talk about is block storage. Now, block storage is a different type of storage area network technology, which, guess what? Takes your data and breaks it down into blocks. Now, because block storage is also network storage, the fastest throughput you'll get will be limited by your network speed, your network card speed, your network interface speed. So keep that in the back of your mind. Now, why do we use block storage and why do we love it? Well, with block storage, we take our data and break it down to blocks. But what's so interesting about block storage is we can place these blocks anywhere in our storage area network. So it doesn't have to be attached to the server. It can be anywhere that we've got IP connectivity to or network connectivity to. So as such, block storage totally decouples the servers or the compute and the storage, which means you can scale. So block storage is a brilliant form of a storage area network, especially in the cloud environment. Now, block storage isn't fast, even though the cloud providers will want to tell you how blazingly fast it is. It's not. It's the fastest of the cloud storage, but it's much slower than the kind of storage that's actually in the server themselves. So whenever we're dealing with the servers and the cloud providers, we basically get some form of instant storage. Maybe called ephemeral storage or instant storage, but what it is, it's the storage that comes in the server. But in the cloud, unfortunately, the storage in the server or that instant storage or that ephemeral storage, whatever we want to call it, doesn't survive instance termination, etc. So because of that, we can't have storage which goes away if we lose the server. So we use block storage in the cloud for those reasons. Block storage is the best performing storage, although it's not the fastest storage, it's the best we're going to get in the cloud. Now, in the data center, you may see block storage plugged in via fiber channel card. And if we go to the cloud providers' data centers, we may still see that. Of course, we could also see them being plugged into the IP network using IP network protocols for block storage as well. So now you know why we use block storage. We use it because it feels like a hard drive, even though it's not. It feels like it's local file storage, even though it's not. It feels like the hard drive in the system, even though it's not. That's why we use them in the cloud environment, and that's why block storage is ubiquitous. Now, if we call Dell EMC or IBM, we buy block storage. But when we go to the cloud, guess what? Of course, the cloud providers have to come up with their own fancy names for this data center technology. So AWS calls it elastic block storage, Azure calls it Azure Disk Storage, and Google calls it a persistent disk. Here's the thing. It's the same thing. It's block storage. It's what we use to mount to our servers because it feels like a hard drive that's local, even though it's over the network. Now let's talk about the last kind of storage, which I'm sure you're familiar with, file storage. Got a hard drive in your computer? You've got file storage and you're using it. Now, with regards to file storage, you store files. Okay. Now, file storage could be local to your computer and its hard drive, or it could be on something called the file server. So most organizations, they have file servers. And if you're on a Windows system, you map to the network drive. You make it look like a drive letter and you store and retrieve things from the files. And why do you do that? It's stored on the server and not your computer, which means other people at your same company can access the data that you save. That's why we use file servers. So let's say, for example, we had 10 Unix servers that all needed access to the same information at the same time to do their job. We would need file storage. Now, we could have 10 Windows servers that also need access to this file server. That would also be file servers. So now you know what the point of that is. Now, when we use file storage, there's basically two protocols we use. If we're dealing with Unix hosts or Linux hosts, we're dealing with the network file system for file storage, invented by Sun Microsystems a long time ago. If we're dealing with Windows systems, we're dealing with server message block file storage and file storage protocols. That's it. So NFS for the Linux and Unix, Windows uses server message block or SMB. So now you know. But guess what? If you're on the cloud providers, they have file servers for you too that are fully managed. Or guess what? You could create your own file server by creating a virtual machine, attaching a block storage to it, and then creating a file share. But let's talk about the managed storage services the providers have. AWS has the Elastic File System. Guess what? That is file service for Linux and Unix systems. It's just like Sun's network file system. Guess what? We have Azure Files. That's file sharing services on the Azure cloud. And with Google, we have Google File Store. So now you know about object storage in the data center and the clouds, block storage in the data center and the clouds, and file storage in the data center and the cloud. What did we talk about today? We talked about server virtualization and how it works. We talked about containers and how they work. We talked about load balancers, the type of load balancers, how they work in the network and data center, of course, the cloud. And we talked about file storage, how it works in the network and the data center, and how it works in the cloud. And if you want a cloud architect job, solution architect job, or a good cloud engineer job, it's great for you to know these things. Know the cloud, and you can work anywhere you desire. I am Michael Gibbs. I am the founder of CEO and Go Cloud Careers, and I want to help you get cloud hired or cloud promoted. I look forward to seeing you in another video coming very soon. Take care. It was so nice having you join us for this video today. Let me tell you about some free services we do for the cloud community. Once per week, we actually have a free question and answer session live on YouTube, where you can come and ask us any questions you want about building your career related to cloud computing or networking, and we'll answer them in real time for you because we want to get you to your goals. Several more times per week, we have guests from industry experts that I've known for decades that are movers and shakers that have changed the world, that can give you information so you can build the best career. I invite them periodically. They are on my show. If there's a chance to do some free training on our channel, we'll do it live because we want you to all to have the best skills for the best career. So please subscribe and hit the bell. I look forward to seeing you, and I look forward to assisting you in your technology career. Thank you so much. This is Michael Gibbs from Go Cloud Architect.